All right, the last part of chapter 2, 2.4. I'm going to start off with just one definition. And that is the system of three linear equations. Okay, we did that in 1.4. Remember when we had x plus y plus z equals a number, right? Then we had x plus y plus z equals a number, and so on. Okay. In order to solve for three variables, so to solve for three variables, you need three equations. Okay? You cannot have three variables and two equations. Okay, that will not work out. That will not work. You need three equations to solve for three variables. Okay. In this lesson, we're going to be using these two equations: vertex form and intercept form. Okay? Now, down here, it says write an equation of the parabola in vertex form. In vertex form. Okay, vertex form is the one we like. The one we already, they give you the vertex, x minus h squared plus k. And they give us the vertex here. It's right at 2, negative 2. So we're going to plug that into our equation. We're going to plug that in. We have y equals a times x. It's minus 2 because it went right 2 squared. And then it's minus 2 at the end because we went down 2. Okay, that's my vertex. They give us a point, 4, 6. We're going to plug those into x and y. So 6 equals, you know that x is 4, and then just everything else. 4 minus 2 squared minus 2. Okay, we have a out front. Sorry, I almost missed that a. That's very important. We need to solve for that a. So we get 6 equals a times 2 squared minus 2. Keep going, we get 6 equals a times 4 minus 2. I'm going to rewrite this so it looks a little nicer. 6 equals 4a minus 2. Add 2, we get 8 equals 4a. Divide by 4. A equals 2. So my equation of this parabola here is y equals a, or sorry, not a, we just solved for it. Y equals 2 times x minus 2 squared minus 2. That is my final equation. Erase a little bit of my equation up here. This one on the right, number 2. We have a vertex at 0, 3. So just plug that in. Y equals a times x minus, it didn't move left or right, 0 squared. It went up 3. And now take my point, 2, 1, and plug it in. 1. Remember, we have to make sure we get our x's and y's straight. So 1 is y. We're going to solve for a. X is 2. And solve. 1 equals a times 2 squared plus 3. So we get 1 equals 4a plus 3. I'm going to subtract 3 from both sides, so I get negative 2 equals 4a. Divide by 4, I get negative 1/2 equals a. So my equation of this parabola is y equals negative 1/2 times x. Oh, it's x minus or plus 0. What's x minus or plus 0? It's just x, right? So I just have negative 1/2 x squared and then plus 3. That is my equation of that graph. Down below, here they give us our vertex, so we are going to write that in our equation. Y equals a times x, and it's at -1, -8. So remember, we have to think opposite in our x, and then -8 at the end. It passes through these points. So we're going to plug in 0 for y equals a times -3 plus 1 squared minus 8. 0 equals a times -2 squared minus 8. Keep solving. 0 equals, looks like we're going to get 4a again, minus 8. Add 8. A equals 2. So my equation, y equals 2 times x plus 1 squared minus 8. All we're doing is taking this equation down here and bringing a and throwing it in. So we're done. So you guys can do the last one on your own. I'm going to move on. This one says intercept form. Intercept form. That is y equals a times x minus h. Nope, not x minus h. My apologies. It's x minus p times x minus q. And we remember, we think opposites with x intercepts. So they give us one intercept at x is -4. So our equation is going to be y equals a times x. Because it's -4, we're going to write plus 4. And then they give us one at 6, so it's x minus 6. Okay, and again, same process. We have to solve for a. So they give us point 125. So 25 equals a times 1 plus 4. Remember, we're just plugging in x and y. Times 1 minus 6. Keep solving. 25 equals a times 5 times 1 minus 6 is -5. So you get 25 equals -25a. Divided by -25, -1 is equal to a. So my equation is, I'm just copying this down, but instead of a, I'm going to have -1. So y equals -1 times x plus 4 times x minus 6. And number 6 over here. My x-intercepts are -4 and -3, so I'm going to have y equals a times x plus 4 times x plus 3, and plug in x and y. Remember, this is x, this is y. That's how we always plot points. So, -1/4 equals a times -3.5 plus 4, -3.5 plus 3. Okay, simplify. -1/4 equals a times -3.5 plus 4, that's 1/2, times -3.5 plus 3, that's -1/2. So I get -1/4 equals 1/2 times -1/2 is -1/4. A. Now, how do I solve for a? I'm going to multiply by the reciprocal, -4 over 1, or just -4. Okay, what happens? 4's cancel out, 1's cancel out, negatives cancel out, everything cancels out, so we're just left with 1. A equals 1. So my equation, right here, I'm just going to get rid of that A, and I'm going to throw a 1 in there. And I really don't even have to throw the 1. Okay, it's just x plus 4 times x plus... Okay, moving on. I'll do one example here, and then leave the last one again. So we have x-intercepts of -5 and 8, so I have y equals a times x plus 5 times x minus 8. Then it passes through 1 and 84, so we have x, we have y. 84 equals a times 1 plus 5 times 1 minus 8. So I get 84 equals a times 6 times, that's -7. So I get 84 equals -42a. Divide by -42, I get -2 is equal to a. So in my equation, oh, I have that whole a, so I have to rewrite it. Y equals -2 times x plus 5 times x minus 8. You can do the last one on your own. Okay, now, this is where this lesson might be a little difficult. We have to analyze the differences in the outputs to determine whether the data is linear, quadratic, or neither. If linear or quadratic, we have to write an equation that fits the data. Okay. First thing we're going to do is determine whether the data is linear, quadratic, or neither. Okay. There's a trick to doing that. The first thing we're going to do is find that first difference. So between 424 and 416, what's the difference? Well, if I took 424 minus 416, I'd just get 8. Okay? 416 minus 376, I'm going to get 40. Okay? 376 and 304, I'm going to get 72. 304 and 200, I'm going to get 104. And 264, I'm going to get 136. Now, if those differences were the same, I'd have a linear graph. Since they're not the same, we're going to find the second level of differences. 8 and 40. What's the difference between 8 and 40? It's 32. What's the difference between 40 and 72? It's 32. Between 72 and 104, it is 32. And I bet you can guess what that next one is. That's right, it's 32. Okay, that's called our second level difference. And when these are the same, we have a quadratic function. Data. We'll just say quadratic. It is quadratic. Okay. Try it on the next one. We're not done with this yet, but the next one. The difference here is 6. The difference here, 6. The difference there, 6. The difference there, 6. The difference there, 6. That would be a linear group of data. So we have a quadratic, we have a linear, and down below, in this last table, Okay, find the difference. We have 10, we have 30, we have 90. Okay, and I'm going to stop there. I'm going to stop there. The reason because I know this is 20, and I know this is 60. So my first level differences isn't constant, right? It's not the same. So it's not a linear graph. My second level difference is not the same. So I know it's not a quadratic. This one is neither. So I determined whether they're quadratic, linear, or neither. If linear, quadratic, write an equation that fits the data. This is where it's going to get a little difficult. Okay. The standard form for a quadratic graph, we're focusing just on this first table. The quadratic form is ax squared plus bx plus c. And we've seen this before. We've seen this before, right? We have to solve for a, b, and c. Solve for a, b, and c. Now, in order to solve for 3 variables, how many equations do I need? This comes back from the beginning of this lesson. 3 variables, 3 equations. Three variables, 3 equations. Okay, so I like to stick with small numbers. So my first equation is going to have those 2 results. I know x, right? X right here is 1. That makes it easy. So I'm going to have a times 1, that's squared, plus b times 1 plus c, and my result is going to be 424. That's my first equation, right? And I can simplify this. This is just a plus b plus c equals 424. Okay. I'm going to get rid of everything else, just so I can create lots of room, because I will need a lot of room here. A plus b plus c equals 424. This is my first equation. My next equation is going to have 2 and 16. Okay, so it's going to be a times 2 squared plus b times 2 plus c equals 416. Okay, simplify that. It is 4a plus 2b plus c equals 416. There's 2 equations. My third one, third and final one, that's all I need because I have 3 variables. 3 and 376, right? So a times 3 squared plus b times 3 plus c is equal to 376. Simplify that, I get 9a plus 3b plus c equals 376. Okay. We've seen something like this before, right? We have to cancel out variables. Cancel some things out. My first focus is going to be on all those c's. Just because we have 1 c on all those, it's going to make it easier to cancel out things. Okay, so I'm going to take these 2 equations, and I'm going to make that top one negative. A, negative b, negative c equals negative 424. That second equation is going to say the same. 4a, 2b plus c equals 416. Solve it. I get 3a plus b, c's cancel out, equals 8. Nope, negative 8. Okay. And it's just like what we learned before, right? We didn't use this bottom equation, so we have to use it now. I'm going to use the same thing, negative a, negative b, negative c. Oh, I'll leave it there. Okay, negative a, negative b, negative c equals negative 4, 24. But I'm going to bring down this bottom equation now. 9a plus 3b plus c equals 376. Let's solve. I get 8a plus 2b equals, c's cancel out, right? Equals negative, I think that's 48. Negative 48. Yep. Okay. Now, look what I have. I have two variables in two of my equations. Okay, now I want to create an opposite. If I multiply that top one, this one right here, by negative 2, I'll get negative 2b, and I have a positive 2b here, right? So I'll cancel those out. So I'm going to multiply that top one by negative 2. Which gets me negative 6a minus 2b equals 16. Okay, bring that bottom equation up, we get 8a plus 2b equals negative 48. And solve. B's cancel out. We're left with 2a equals negative 32. So a is equal to negative 16. Okay, I solved for a. That's good. Now I have to solve for b. Plug b back into this equation right here. Or plug a back into that equation. So I get 3 times negative 16, which is negative 48, plus b equals negative 8. Add 48 to both sides, you get b is equal to 40. Okay. And then the top equation, a plus b plus c, we'll just plug in those. Negative 16 plus b is 40 plus c equals 424. That's from that top equation right here. Solve, I get negative 16 plus 40 is, what is that, 24? Plus c equals 424. So c is equal to 400. I solve for a, I solve for b, I solve for c. My new equation, my equation of this graph up here, this table up here, is negative 16 x squared. Right? I'm taking this and I'm plugging it in. I'm sorry, I'm kind of all over the place. Plus bx. What's b? 40. X plus c, which is 400. And there is my function, which is a lot of work. There you go. If you have any questions on that, you can always email me. Or talk to me in class. Down here, this one, we already established this was linear, right? 6, 6, 6, so on. What's my equation for a line? Something we're all familiar with, okay, and should feel comfortable with it. Y equals mx plus b. We're going to solve for that equation. Okay. We can plug in any two points for x and y. I like small numbers, so I'm going to plug 0 in for x and 36 in for y. Anything times 0 is 0, so I get 36 equals b, which is awesome. So that's part of my equation. Y equals mx plus 36. My m is my slope. M is my slope. Slope. And I can find my slope using my table. And remember, the height, that's up and down, right? Up / down. Time in days, or my x, is left / right. And remember, my slope is rise over run. So let's talk rise, up and down. I'm going how far? From 36 to 30, am I going up or down? I'm going down. I'm going down 6. So it's going to be -6. Then I'm going over how many? 3. -6 over 3, simplified, is -2. Lines are way easier than quadratics. Okay? And then last table is nothing. We already established that. So that is it for 2.4.